Hello everyone, welcome back to Smart Interviews YouTube channel. My name is Mohammed Rafi. In today's video, we are going to discuss Codechef Contest Starters 143. Okay, let's get started with the first one. I think the first problem is nothing but maximum coins. Here we'll go with the problem statement ones. They're given Chefina are playing the series of N games. Each game has a winner for ith game. The loser pays 2 I coins to the winner. You're going to find the maximum number of coins Chef can get if he wins exactly X games. Okay, we'll take the example. The sample input they're given 4 and 1, right? We'll pick with the 4 and 1 now. Assume that they're given 4 N games, nothing but 4 games, and Chef is going to win 1 game. Nothing but here 1 to 4 games, right? 1, 2, 3, 4, and 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4. If you see, we have to pay 2 power I coins to the winner. For example, Chef is going to win how many games here? 1 game, right? If Chef is going to win 2 power 1, nothing but first game, so he has how many coins? 2 coins. What about the remaining coins? All coins to the opponent one. Nothing but here we have 4 plus 8 plus 16, right? So nothing but total coins is here 28. Now, by saying this, we can say that 28 coins is for opponent and Chef won 2 coins. And here the opponent is going to win the majority number of coins, 26, right? But what we want here, what the problem statement says, to find the maximum number of coins Chef can get. So what should we do now? It's reverse, right? Same. Why to pick the first one? We want the maximum number of coins. Yes. If we have 1, start from the last side. Simple. 2 power 4. Nothing but Chef will get 2 power 4. Nothing but 16. Chef has 16 coins now. And remaining coins to the opponent. Nothing but 2 plus 4 plus 8. 14 coins. And 16 minus 14. The result is 2. Yes, that's it. What we want? We have 4 and 1. We got 2. So simple. Okay, let's convert this logic into code part. Yeah, let's convert our logic into code part. So what is the input format here? First they are given t, number of test cases. We are going to iterate t times. So the next they are given int n and x. We are going to read it n and we have x. Now we are going to calculate for Chef number of coins and opponent. Assume that P1 is for opponent, player 1, and player 2 is Chef. Now first we are going to calculate all the coins for opponent. So we are going to iterate with the help of follow for int I equal to 1, I less than equal to how many times? N minus x times. N minus x and I plus plus. Then we have P1 equal to P1 plus. Yeah. We are going to power I with the help of left shift operator. This is for player 1 opponent. Same we are going to calculate for I equal to here in minus x plus 1, right? Here and I less than equal to n and I plus plus. Same P2 1 left shift I here. That's it. We are going to print the result now. Nothing but P2 minus P1 with new line. Yeah. Okay, let's run it. Yeah, let's submit the code. Yes, accepted. Good. We'll go with the next one. Yeah, guys, let's start with the second one, binary conversion. The prompt statement is very easy. You're given two string s and t of length n and integer k. You're going to convert string s to t by making exactly k operations. Okay, and you're given k operations, nothing but you're going to pick two index value I and j, which should not equal. Okay, both should be distinct, and you're going to swap the numbers, swap the index characters. Simple. For example, here they're given s equal to 010 and t is 100 and k equal to 1. Okay, with the help of one swap, nothing but I'll swap it 0 and 1. Yes, with the help of one swap, we are going to convert s to t, right? So we are going to return true or else. Okay, now this is a prompt statement which they are given. Let's see the logic part. We'll go with the same string 0 1 0. Now, what is the first step here? What is the first step you will see to convert s to t? Step is simple. Number of 0 and 1 should equal. Yes, number of zeros here is 2, here is 2, and number of ones 1 1. If both string contains equal number of zeros and ones, then it's a possible condition, right? We can. Okay, we can. This is a one step. Okay. Now, this is a one step. Number of zeros and ones should equal in both the strings. Let's move forward. Now, by saying this, we can say k is one, nothing but swap. We require one swap to convert s to t. But how are you going to convert in code? What simple, right? I'll check the both the values here, both the characters and 0 0, both are same. Okay. Now I'll check 190. Yeah, here we got 190, two different one. S of I equal to 1, t of I equal to 0. That means there is one more 0 which is in wrong position. Nothing but this one. We should swap it. So I'm going to count swap required equal to 1. Okay, 1, and here 0 and 1. Okay, we are going to neglect 0. Why? Because already we swap it, right? 0 with 1. Because of that, we got swap required is 1. So we are going to neglect 0. It's based on you. You can go with 0 or 1. I'll go with 1 here. Got it? Now swap required is here 1, and we will check k value. If swap required, okay, if swap required, if it is equal to k, that means yes, we can convert s to t with the help of k, exact k operations. We're going to return true. Okay, this is one condition. But if you see here, the same condition, same string, if k is 2, then k equal to 2, then we'll get swap required is 1. Yes, we'll get swap required is 1. Now the condition is false, right? First we'll check the answer. First we have 0 1 0. I'll swap it. We'll have 1 0 0, and k is 1 now. As the prompt statement mentioned, exactly k operations. What about now? We're left with one more k equal to 1, right? Simple. We have here the length is greater than 2. That means there is a character that is repeated. Yes, here 0 0 is repeated. I'll pick these two characters, swap it, same value. Again, if you see both the strings are same, if you swapped, because the character is same. So what the condition, what should I change here? By seeing the above operations? Simple, right? Swap required if it is less than equal to k. If it is less than equal to k, we can convert s to t. Simple. Let's, but there is a edge condition. I'll tell you. What about if we have two characters, two same characters? S equal to 0, 0, and t equal to 0, 0, and k is equal to 1. Yes, we'll pick simple two indices and we'll swap it. Done, right? What about 2? Yes, we can swap number of times if the both strings are same. Got it? What? What if the strings has distinct different values? 0 1, length is 2, and here we have different one. What about now? and I will give k equal to, first we'll go with 1. Yes, with the help of one operation, one swap, we can convert S to T. What, hmm, what if the k value is 2? What about now? It's possible to convert. In the one swap, we are going to convert 0, 1, and the k is now 1. We need to swap once again. If we swap once again, we're not going to convert S to T. Yes, this is the one edge condition we are going to handle it. Okay, nothing but k modulus 2. If it is not equal to 0, it should be odd. If k is 1, we can swap it. If k equal to 3, we can swap it. Fine, we can swap it. Right? Now we have one more condition, that if s equal to 1, 0 and t equal to 1, 0. Right? If s equal to 1, 0 and t equal to 1, 0 and k equal to 1. Possible? No, right? What if k equal to 2? What if k equal to 2? Yes. First we'll swap 0, 1. Again I will swap 1, 0. Two operations are done. So what is the condition here? Simple, right? If k modulus 2, if it is equal to 0, then only it's possible. Yes? See. These are the conditions. One is nothing but length. We are going to check the length. Then swap required. Then these are the conditions. Edge conditions for length equal to 2. N size equal to 2. Okay. Now we are going to convert this logic part into code. Let's see. Yeah, let's convert our code into logic part. Yeah guys, let's convert our logic into code part. So what is the input format here? We're given t. We are going to read t here. Next we are going to iterate t times. Next, as I said, two spaces of n and k, right? First they are given n and k. We're going to read n and k first, saying length of a string and k operations. Along with that, string is string t, saying s and t. Yep. This is the input format which they are given. Now I'll check if the string is possible to convert s to t or not. So I'll have a function. So we are given pass s, t, n and k. If it is true, we are going to print s with new line. Now let's see. As we'll go with the boolean. First we have string is string t, length of a string and k operations. Now, what is the first thing we have discussed? To check equal number of zeros and ones in each string, right? So we'll have a count variable, okay, count 1 and count 2, and we're going to iterate on a string equal to 0. Next, I'll check if s of I, okay, if it equal to 0, we are going to increment count to 1. Else part, if it is 1, we are going to increment count to variable. Same way I'm going to check if t of I, if it is equal to 0, what I'll do, I'll decrement the count 1 value. Okay, same here. Else, if it is equal to 1, I am going to decrement count 2 value. Now at last, if count 1, if it is not equal to 0, and count 2, if it is not equal to 0, that means no equal number of zeros and ones here, I am going to return simple here Simply return false. Now this is the first thing we are going to check equal number of zeros or ones are there or not in our assigned t. Okay, now what is the base condition we have discussed? If n equal to 2, okay, if n equal to 2, what are the conditions we have discussed? Both the strings s1, nothing but I'll write here, if s of 0 equal to s of 1, if characters are same and strings also same, if character is same and string also same, then we no need to check k value, right? Simple, we can return true here. Else 0 if it is not equal to s of 1. Okay, characters are not same but the string is same, then okay, for example here we have 1010, then yes, right, k should be even, then only we're going to return true here. We have one more condition, if characters are not same, and here strings also not same. Okay, characters are not same. For example, in the first string s equal to 01 and t equal to 10. Okay, characters are not same and strings also not same, then k modulus 2, it should be odd. Return true. Else part, we're going to return false. Everything we're going to return false. And the last step, number of steps, right? So swap required, we'll check how many swaps required. What is the condition? Is of I if it is equal to 1 and t of I if it is equal to 0. Yeah, if it is equal to 0, then we are going to increment our swap required as we have discussed. Next, what is the last condition? If swap required should less than equal to k, then only we are going to return, or else return false. This is our condition, right? Let's run it. Cool. Got it. Let's move to the next one. Yeah, guys, let's start third solution. The third one, non-divisor array. You are given an integer n. Your task is to find the minimum integer c such that there exists an array of size n. Okay, you're going to create an array of size n, and the value of the array should less than or equal to c. Okay, and they given one more condition that x and y, you're going to pick x and y indices where x divides y. If it is divides, the value should not equal. Okay, value should not equal. For example, I'm going to pick if n equal to 6. Okay, right. If n equal to 6, we'll go with one base index. Okay, first what I'll do, first I'm going to place the numbers. First I'll place 1. Okay, next I'm going to place 2. Why I'm not going to place 1 once again? Because all the numbers are multiples of 1. As I said, the value should not equal if it is multiple. Okay, what about 3? I can place 1. What about 2? Can I? Yes, I can. I place 2 here. What about 4? I can place 1. I can place 2 because 2 is multiple of 4. But yeah, so I place 3 now. Now what about 5? I can place 1, but can I place 2? Yes. What about 6? 1 is not possible. 2 also not possible. 3? I can. If I increase the number 7, 8, 9, 10, now. So for 7, can I place 1? No. What about 2? Yes, I can. 8, I can place 1. I can place 2. I can place 3. Okay, so I'll go with 4. What about 9? Yeah, simple. I'm not going to place 1. 2. What about 2? Can I? 9 value. It is not a measure of, right? But 3 is there right here. Index 3. So can place 3 there. So yeah, I'm at 2. What about 3? Value 3. Yes, we can. So on. Okay. Let's see how we are going to place the numbers. Okay, this is a problem statement. Now let's see how we are going to place the numbers 1, 2, 3, so on. Okay. Did you observe anything from this array which we have filled? If you see the prime indices 2, 3, 5, 7, okay, so on, have the same values, have the same values. So what can be done here? We are going to create an array. Okay, if it is prime, we are going to fill with the value of 2. Simple. Initially, the value 1 is index value 1 is 1, obviously. Okay, we'll start with 2, 3, 4, yeah, 2, 3, so on till n. But what about the remaining values? What do you think about the remaining values? How can we fill the values? We can do one thing. Okay, we can do one thing. As they mentioned, in case of multiple satisfy, you may print anyone, right? If there are multiple arrays, you can print anyone. What we'll do? The same logic. If it is prime, we are filling the same numbers, right? So what I'll do is same condition. If it is prime, I'm going to fill the same values. We'll see the remaining values. Okay. Now, so yeah, first what I'll do, I'll fill all the numbers. If it is a prime number, I'll fill 2, 2, 2. Okay. Let's check the next values. I place something like count variable, something like that. Okay. Yeah, here I'll check 4. 4 is not prime. So what I'll do, initially assign count with 3 because 1, 2 is already filled. Because of that, I'll count variable. I'm going to assign with 3. I'm going to fill with 3 here. Okay, next step. I'm going to place index 4 as 3. All the multiples, okay, all the multiples will go in the reverse order now. Okay, who is not multiple of 4? Okay, I'm going to fill with 3. Okay, here one more condition 2, 3, 5 also to write. Uh, all the not multiples of 4 I'm going to place with 3 value, nothing but 6 I'm going to place 3, 8 is we can place 3 here, 9 we can 3. Now I will check for 8. Now I'll check for 8. It is not multiple. Okay, when I place the value, I'm going to increment the value as 4 now. If I place the value, I'll increment the value. Count equal to count place 4. I'll check. I can place 4 now. Okay. Now what is the condition? All non-multiple of 8, I'm going to place with 4. I can override. So on. Okay, this is our logic. Now, simple, right? First step, we are going to check if it is prime or not. If it is prime, I'm going to fill with the value 2. If it is not a prime number, I'm going to pick number. I'm going to place all non-multiples of index the same value and increment the value. Okay, so on. So first step. So if you check is prime or not, it will take time, right? Inside the test cases. So what can be done here? We can, right? The size of the array is 10 power 5. We are going to create an array, something like prime of 10 power 6. Okay, as prime with the help of prime sieve method. I'm going to fill all the array, nothing but boolean array. If the index value is true, even index value is prime, I'm going to place with true or else false. Okay, so it will reduce our time complexity to check the value is prime or not. Got it? Cool. Let's convert this logic into code part. Guys, let's convert a logic into code. As we have discussed just now, we are going to pre-compute all the values of prime first with the help of prime sieve method. I hope everyone knows what is a prime sieve logic part. Simple. everything I'm going to initialize with false. Yeah, my bad, true now. Index and the value. Next, what I'll do, I'll just write is prime of 0 index. Obviously it should be false. What about first index? Yes, same false. Now I will check for the remaining values. I'm going to fill all the values, okay, if with the based on index. For example, 3, 5, 7, 9. If the value is, yeah, if I'm going to pick 2, all the multiples of 2 I'm going to make us false, because 2 is a prime number. All the multiples of 2 is not prime, so I'm going to convert as false. So just write for int, yeah, we'll iterate till less than equal to n here, and I increment. I'll check first if is prime. First I will check is the value is true. Yes, if the value is true, for example, assume that the index value is initialize I equal to 2. First we have 2. Yes, 2 is true now. I'll pick 2. I'm going to convert all the remaining values of multiples of 2 is false as false. For int j equal to j less than equal to n. Now there's a condition, right? What is n here? You may think, what is n? Yes, as I said, we're going to convert n equal to 10 power 6, okay, as 10 power 6, or else if they see the value 10 power 5 into 2, so we'll just try 10 power 6. So we'll check is prime. If it is j is prime, just I'll convert equal to false. Okay, yeah, this is our method to fill all the prime numbers in the array. Okay, now let's move on to the problem. What is the input format? First they are given t as number of test cases in t. We're going to iterate on t. Next, we'll check. We are given the values n, so we'll read n. Now, what we discussed, same implement. Okay, we are going to implement the same. We are going to declare a vector of integer now as array, okay, of size n plus 1. I'm going to initialize everything with 0. Okay, I'm going to initialize everything with 0. Initially everything should be 0, and I will write array of 0. Obviously first index should be 0. We are not counting the first index, nothing but 0 index. We are counting from the 1 base index, right? So array of 1 initialize with 1, and array of 2 I'm going to initialize with 2, as we have discussed. And the same, and count variable I'll start with 3. Why? 1, 2 are already filled. We'll start with 3. Now we'll check. Now we are going to check. Yeah, next we are going to start with an array in I equal to 3, because we have filled 1, 2. We'll start with 3. I less than equal to n, and I plus plus. First I will check if the index value, if I'll check is prime of I. If the value is true, what we will do? Simple. We are going to assign the index value array of I equal to 2. So array of I equal to 2. As we have discussed, if the prime number is there, we initialize all the values as 2 here. Next, else if the value is 0, okay, if the value is 0, and yeah, we can check that if the value equal to 0, we didn't fill anything, right? Array of I, if it is equal to 0, if array of I equal to 0, so I'll just write array of I, I'll initialize count, then I'll iterate with the help of for loop equal to something I plus 1, j less than equal to n, and j increment. I'll check if it should not prime. Okay, and multiple, nothing but j modulus I should not equal to 0. If condition is true, I'll insert array of I equal to count, same value. After inserting, I'll just have increment the count number. Then we did filling part. What is the next part? We should find our answer. So I'll iterate on the array. Start with 1. So I'll check I have max of our answer, array of I, finding it. I'll print answer with new line. Then I'll iterate once again to print the array elements. We are having the one base index. So I print array of I, yeah, with just space. After printing, we'll just one more have new line slash in. We'll check. If you see here, not right. What we'll do, I'll just write array of j to equal to false. Okay, and here is array of j not I. Good. It's on the code. Yeah, guys. Thanks for watching the video. If you enjoyed it, like the video and share it. For more such content, subscribe our channel. Thanks. Bye.